Welcome to another explainer. So today we're looking up at the night sky, right? But we're not actually going to focus on the bright, shiny things you're used to seeing. Nope. Instead, we're exploring a genuine cosmic mystery. We're asking what exactly lies beyond the obvious, luminous parts of a galaxy. We're talking about the unseen engine of the cosmos, the Galactic Corona. Okay, let's dive into this. When you picture a galaxy in your head, you probably think of, brilliant swirls of light, massive clusters of stars, those really bright glowing disks. But what actually exists beyond those visible stars? Today, we're intentionally shifting our focus away from those bright, obvious structures, and we're venturing out into the dark, hidden architecture that surrounds them all. Section 1. The Hidden Galactic Halo. So, to really understand our universe, we have to look way past the dense center of a galaxy and peer out into this vast region we call the halo. And right there, hanging out within that halo, is exactly what we're looking for, the Galactic Corona. Now, what is that? Well, the Galactic Corona is basically a thin layer of hot, extremely diffuse gas. But hey, don't let the phrase thin layer fool you into thinking it's not a big deal. This gas is spread incredibly thin across literally massive cosmic distances, but it is also insanely hot. We're talking temperatures reaching millions of degrees here. This superheated, super diffuse gas forms the foundational subject of our explainer today. And this brilliantly illustrates the massive visual contrast we're dealing with when we study these environments. On one side, you've got the highly visible stars in the disk of the galaxy, right? Those blazing light sources that immediately catch our eyes. But then, on the other side, the Galactic Corona is just, it's much, much less visible, mostly because the gas making it up is so extremely diffuse. It's a really striking comparison between that brightly illuminated disk of stars and the practically invisible corona that just kind of envelops the whole shebang. Section 2. Detecting the unseen gas. So you might be wondering, if this hot gas in the corona is so incredibly diffuse and, practically invisible, how on earth do we even know it's out there? Well, to find it, astrophysicists kind of have to act like cosmic detectives. They can't just rely on your standard optical observations that look for visible light. Instead, they turn to some very specific tools: radio and X-ray observations. See, because this gas is heated to such absolutely extreme temperatures, it interacts with energy in ways that optical telescopes just simply can't pick up. These specialized methods act as literal lenses into the invisible halo, and they allow researchers to piece together what's otherwise totally hidden in the dark. Now, what's really interesting is exactly how those radio and X-ray observations actually work in practice. Researchers aren't just looking for some solid, glowing object out there. Actually, the detection relies entirely on spotting specific emission and absorption signatures. Think of these signatures like unique cosmic fingerprints left behind by the gas. As background light travels through the halo, the corona absorbs very specific wavelengths. And similarly, its highly energized particles emit their own faint little signals. When scientists spot these specific fingerprints in their data, boom, it definitively confirms the presence, the temperature, and even the chemical makeup of this extremely diffuse halo gas. Section 3. Regulating galactic material. Okay, so we know the galactic corona is there. We know it's extremely diffuse and incredibly hot, and we know exactly how to spot its signatures using X-rays and radio waves. But what does it actually do? Well, so the crucial point is this. This hot gas functions as a massive mechanical engine that regulates how galaxies gain or lose material over time. It's not just sitting there passively. The corona actively interacts with matter expelled by stellar explosions. When supernova blast heavy elements completely out of the galaxy, the intense heat and pressure of the corona step in and act kind of like a giant thermal blanket. It actually traps this escaping material, cools it down over millions of years, and eventually cycles it right back into the galactic disk to fuel brand new star formation. And at the exact same time, its dynamics determine if some of that gas just escapes into deep space forever. It is literally a hidden regulatory force overseeing the physical resources and the entire life cycle of the galactic structure. Which brings us to one final, really provocative thought. With this invisible gas acting as a regulatory engine, how does the corona ultimately dictate a galaxy's lifespan? I mean, think about it. If this hidden halo determines what a galaxy gains and loses, if it literally manages the very fuel required to birth new stars, it's essentially the master regulator of a galaxy's long-term evolution and survival. Without this unseen engine doing its job, a galaxy would quickly burn out and just fade away. It's a perfect reminder that sometimes the absolutely most crucial engines in the universe are the ones we can barely even see. Thanks so much for joining me for this explainer, and hey, keep looking beyond the visible.